Now we are going to learn about type of sets. So how many different type of sets are there? So the first one is empty set. So from the name itself, it says empty set means what? The most important thing of a set is what? Element, right? If there is no element, then the set is known as empty set. A set which does not contain any element. Okay. Now it is denoted by two brackets and nothing inside the brackets. Okay. Now it is also denoted by this sign. Okay. So this, if you see this sign, then you can see that it's an empty set. Clear? Okay. Now empty set, also known as null set or void set. When you hear those terms, you think of it as empty set. Now let us say an example. Let us see what's an example of an empty set. Now x is an even prime number greater than 2. Actually there is no even prime number which is greater than 2. Can you think of? No. Because if we have an even prime number greater than 2, so suppose we say 4, it has a multiple of, it is multiple of 2, right? Clear? So it is not a prime number. Okay, there is no prime number greater than 2 which is even. Now let's move on to next one. Finite and infinite sets. A set which contains, now finite means what? Something which you can count. Okay, and infinite means what? Which is uncountable. So from here, finite set will be what? A set which contains a definite number of elements is called a finite set. Simple as that. And what do you mean by infinite? A set which does not contain a definite number of set. It will be infinite set. Simple as that. So example, x is a positive integer less than 10. So x is a positive integer less than 10. It will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? 0 is an integer, but is neither positive nor negative. So it will start from 1 and it is a finite set. Now it says x is an integer greater than 10. So if you think of x is an integer greater than 10, it will be 11, 12, 13, 14, 15, 16, 17. It will go on like that. And that will be an infinite set. Clear? Now we are into equal set. What are equal sets? So now two set A and B are equal when they have exactly the same elements. Suppose if I say A has 1, 2, 3, then B also need to have 1, 2, 3 to be called equal sets. So it is written as A is equal to B. So let's say an example. A, x is a prime factors. So one thing, this example, there is a problem. So just think of it like this. If I say, let's give you an example. This example, don't look at this example, it's wrong. So I will just give you an example. Suppose x, I give you A is equal to 1, 2, 3. This is one set A, and the other set B is equal to 3, 1, 2. You see, the order is not important. If I see the elements are same, 1, 1, 2, 2, 3, 3, then I can say what? That these A and B are equal sets. Am I clear? Okay, let's move on to the next slide. Now we know subset. So what are subsets? A set A is said to be a subset of a set B if every element of A is also an element of B. Okay, if A, so what do you mean by, forget for the moment, don't read this thing, just see. A set A is said to be a subset of B. So when can I say a set is a subset of B? Another set, if every element of A is also an element of B. So if I say A is equal to, if I say A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5. Clear? So what we say that every element of A, 1, 2, 3 is also an element of B, right? Then we can say that A is a subset of B. Understood? And it is denoted by, what should I denote for here? It will be A. This is a subset sign. Clear? A is a subset of B. Understood? This is how we denote. So it says what? This is how we denote only when if A is an element of A implies that A is an element of B. Okay, 1 is an element of A, 1 is also an element of B. Then only we can say that A is a subset of B. Understood? Now if A is not a subset, then we can denote is, we will just write a subset like this and like this. So how can I say that it's not a subset? You see like this. If I remove 2, right? If I have this element 1, 3, 4, 5. Now all the elements of A are not present in B, right? Because 2 is not there. So A is not a subset of B. Understood? Now phi, what is this thing? It was empty set, right? Now if I have an empty set, if I have empty set like this, if nothing is there, right? So now if nothing is there, obviously it is a subset of this thing. Yes or no? It's nothing in there. Again, if nothing is there, it is still a subset of this thing. Yes or no? If nothing is there, it's still a subset of this thing also. Yes or no? Any set is a subset of itself also, because all those all I have to check whether all the elements of this one is contained in here or not. You see nothing is here, nothing is here, so subset. You see nothing is here, 1 is here, I don't care, nothing is in here, so it's a subset. So A is a subset of B. So what we can say, the empty set is a subset of every set. Am I clear? Empty set is a subset of every set. Now here we have given an example. A is 1, 2, 3, B is 2, 1, 3, 4, where A is a subset of B. Why? Just look at those elements. 1 is there, 2 is there, 3 is there. So A is a subset of B. Clear? Now you see, if A is a subset of B and A is not equal to B, look at here, A is a subset of B, right? Is A equal to B? A will only be equal to B when all the elements of A is same as the elements of B. You see 4 is not there, right? So A is what? Not equal to B. Then I can say A is called the proper subset of B. Okay? A is the proper subset of B when A is a subset of B and A is not equal to B. Understood? And B is called the superset of A. Okay? So if A is known as the proper subset of B, then B is known as the superset of A. Understood? Clear? Achha, look at this one. 1, 2, 3, 2, 1, 3, 4. Can I say this one? B is a subset of A. No, it's not possible. Why? Because you see 4 is not there. So B cannot be subset of A. Understood? Clear? Okay, now let's move on to the next one. It says subset of set of real numbers. Now subset of set of real numbers is what? You see here, N is for natural numbers. Natural number is a subset of whole numbers. Am I clear? Because natural number starts from 1, 2, 3, 4, 5, 6. It goes on like that. And whole number starts from 0, 1, 2, 3, 4, 5, 6. It's like that. So natural number is a subset of whole numbers. Now whole numbers is a subset of integers. Now integers means what? It's from minus infinity to minus 2, minus 1, 0, 1, 2, 3, 4 like that. Now integers is subset of rational numbers. Now rational numbers also contains 1.1, 1.2. It contains 1, it contains minus 1. But it contains as well minus 1.5, all those. So integers is a subset of rational numbers. Now rational numbers is a subset of what it says. Rational numbers is a subset of real numbers. Why real numbers? Because real numbers are divided into two parts. That is rational number and irrational numbers. So rational number is a subset of real numbers. Now irrational number is also a subset of real numbers. But natural numbers is not a subset of irrational numbers. Am I clear? Because natural numbers are what? 1, 2, 3, 4, 5. But irrational numbers are what? Which we cannot express in the form of P by Q. Which has non-terminating, non-repeating decimal expansion. We have learned this one before. Understood? Now let's move on to this one. Intervals as subsets of R. Now intervals as subsets of R. What do you mean by that thing? So it means that suppose I have a like this, a sign like this. We have third bracket A comma B. Suppose I have like this, A and B enclosed in third brackets. Now this means actually, this is what set builder form, where x is greater than equal to A but less than equal to B. This one is a closed bracket. Am I clear? What does it mean? It means closed interval including A and B both. What do you mean by including A and B both? X is equal to A also, X is equal to B also. Understood? So if I have a number line like this, understood? So -2, -1, this one is 0, this one is 1, this one is 2. If I ask -1 to 2, so it will be what? It will be from here to here, and it will be include -1 and 2. Understood? Okay, so you will just circle these points if you include. We circle the points if we include those points. Clear? Understood? So it's a closed interval including A and B both. Now let's move on to the next portion. Now next portion says what? It is close bracket in one side but first bracket in the other side. First bracket means open bracket. You see here it's written as x is greater than equal to A. Equal to A, why? Because it's close bracket. Now there is no equal to sign. So x is just less than B. So why? Because it's an open bracket in here. So it means this is an open interval including A but excluding B. So the gate is closed in the side of A but the gate is open. I just kicked B outside. Okay, so there is no equal to sign. So this one will be denoted as like this. So if I have a number line like this, so it is 0, it is 1, this one is 2, this one is -1, this one is -2. So if I have this one as from -1 to 1 like this, so what happens? I will give it a circle and I will darken it and I will have a hollow circle in here and it will be from here to here. Understood? Clear? That's what it means. Okay, so this side is open and this side is closed. So I will include -1 but exclude 1. Clear? Now we have the last one. The last one is both side it's open. So here it says A comma B. So the gate is open this side also, the gate is open this side also. It means what? I'm kicking both of them outside from the left and right hand side. So it is open interval excluding A and B both. So I'm excluding A and B both. So suppose I have a number line 0, 1, 2, -1, -2. Suppose I will write -2 to 2. If I have like this, -2 to 2. So it will be what? A circle like this, a circle like this. Both it will be hollow, but it will denote the points between -2 to 2, but there -2 and 2 are not included. Am I clear? This is for open bracket. Okay. So let's move on to our last slide. Now it says power set. Now what is power set? The collection of all subsets of a set A is called the power set of A. Understood? Listen very carefully. The collection of all the subsets of a set A is called the power set of A. Now look at here. Let's solve an example. Suppose I have a set as 4, 5. Okay. Now let us write the subsets of A. So what are the subsets of A? If I have a subset of A, look, this empty set, we have already learned that empty set is a subset of all the sets, right? Of every set. So empty set is a subset of this one, right? Now, can you tell me, is this set a subset of this set or not? Yes, it's a subset of this set. Why? Because 4 is included in here, right? So this is a subset of this one. Now, tell me, Is this a subset of this one or not? Yes, this is also a subset of this one. Why? Because 5 is in here, right? So this is also a subset. Now, next one, tell me. Is this one a subset or not? Tell me. Is now all the elements 4 and 5. This is also all the elements 4 and 5. So this is also a subset of this one, A, right? So this is also subset. Now, can you think of any more subsets of A? There is no more subsets of A. Understood? So these are the 4 possible subsets of A. Now it says what? Now read it carefully. The collection of all subsets of a set A. We have listed all the subsets of set A. The collection of all the subsets of set A is called the power set of A. The collection of I have collected all the subsets of A, and the collection of all those subsets gives us the power set of A, and the power set of A is denoted by P of A. Am I clear? So what is power set of A? Collection of all the subsets of A. Understood? Okay. Now you see here, now then example is given, A is 1, 2. Then P of A is equal to power set will be 5 is there, 1 is there, 2 is there, 1, 2 is there, right? Now a question comes, what is the number of elements of the power set of A? Can you tell me what is the number of elements in here? 4 elements, right? Now how did we get the 4 elements? Actually, we'll follow a formula. It is basically 2 square. Why 2 square? First I will write 2, and in the head will be the number of elements whose power set we are finding. Here A was what? 4, 5. So how many elements? 2 elements. So the number of elements of the power set of this one will be 2 square. Understood? Here, how many elements? 2 elements. The number of elements of the power set of this one will be 2 square. So suppose I say there is a set 1, 2, 3, 4. Okay, suppose there is a set. B is this is equal to this thing. Now if I ask you, what is the number of elements of this one? What is the number of elements? Now it is denoted by this thing. N comma this thing. N means what? Number of elements of this power set of B. It will be how much? Equal to 2 to the power. How many elements of B? 1, 2, 3, 4. That is 4. So it will be 16. Understood? So that's how we find the number of elements of the power set of any set. So in general, what we say, if A is a set with now A means what? Number of elements of A. Now if number of elements of A is M, if number of elements of A is M, then it can be shown that number of elements of power set of A will be 2 to the power M. It's so easy. Understood? Clear? Let's move on. Now it says universal set. Now from the very word of it, universe, universal, you are thinking of universe. Universe means what? It will have everything in it, right? So the collection of all possible elements of the set is known as universal set. Now it is denoted by U. It's simple as that, because the first letter is U, so that's why it's denoted by U. Now let's just give an example. Now suppose there is a set A, which is X is an English alphabet, right? Now for English alphabet, the universal set will be what? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So a set in which all those elements are there is the universal set. Can you think of any more alphabets, English alphabets other than them? No. So that's the universal set for English alphabets. Understood? Clear? Okay.